I want to find the voltage drop V0 across 10 ohms here, and I will use Thevenin's theorem to do that. So what I will do, I will first remove the 10 ohms resistance and find the open circuit voltage. So in order to do that, I'm just redrawing the circuit. So that's here, and this one is now open here. I want to find what is the open circuit, that is VOC, open circuit voltage here, which is my VThevenin's voltage. So with this circuit, what I can do, I can see that there is a current source and a parallel resistance, 3 amps current source and 16 ohms parallel resistance. So I can convert it into a voltage source and a series resistance. So I will do that. There will be a voltage source here and a series resistance. So that is my up to here, this terminal there. So these two terminals, and then I have another resistance there, and then the 5 ohms here, and there is this other voltage source, and here is the VOC there. So that's 1 ohms, and this one is 5 ohms, 12 volts. So 5 ohms there, 12 volts there. So these are just the given resistances. I haven't changed anything. This is the changed part. So the resistance will be same. The series parallel resistance will now become series resistance, 16 ohms, and the voltage value of the voltage source will be 3 times 16, that's 48 volts. So that's the value of the voltage source. So now since this one is open circuit here, I have only one series circuit and just one current there. Let's call it I, and I have two voltage sources. One is 48 volts and one is 12 volts, and they are opposing each other. So the current I, if we want to find the current I, will be 48 minus 12, since these two are the voltage sources here, EMF, basically electromotive forces, and the summation of the resistances. So that's 16 plus 4 plus 5, so that's 25. So 36 over 25 amps. Let's leave it like that. That's the current. Now I need to find the voltage, open circuit voltage, which is here, VOC, which is pretty much the voltage drop across the 5 ohms resistance, whatever it is, and summation and the sum of 12 volts, because these two are, when added, that gives me VOC, because there is no current here, so there is no drop here when the circuit is open. So VOC will be just the voltage drop across 5 ohms resistance plus the voltage source 12 volt, because when I'm going in this way, that's a drop there, this way, that's a drop. So 5 I have written V5, that means the voltage drop across the 5 ohms resistance. So that is the current times the resistance, that times the resistance plus 12 here. So that is 36 over 5 plus 12, which is 7.2 plus 12, so that is 19.2 volts. That is the open circuit voltage or Thevenin's voltage. So if I draw the Thevenin's circuit, this will be the Thevenin's voltage, which is 19.2 volts, and then I will need Thevenin's resistance, which I will find out later. Now, sorry. So that in order to do that, what I will have to do, I have to make all the sources inactive in the original circuit, or maybe in the transformer band. Let's do in the original circuit. So instead of redrawing, what I will do, I will just look in the circuit. So I want to make the current source inactive, so I just take it off. So open circuit here, so basically the current source is gone there, and this is just the open circuit now. So these two are like that, and then there is this voltage source which is 12 volts. This in order to make it inactive, I need to short the two terminals. So I remove it, and then I short circuit. I just short these two terminals there. So that's there. Now I am looking at the resistance. I will erase this part because I just want to find the resistance looking from here. And when I look at this one, the resistance that I see now is 16 and 4. These two are coming in series and it's parallel with 5 ohms. So basically I have 16 plus 4, which is 20, parallel with 5, and then again series with this 1 ohms resistance, because I'm looking from here, so I have to add 1. So 20 parallel 5 is 4. 20 times 5 divided by 20 plus 5, so that's 4. So 4 plus 1, so that resistance is 5 ohms. So that's my Thevenin's resistance. And in the original circuit I was interested in finding the voltage drop across the 10 ohms resistance, which I removed. So now I reconnect it, because this is the resistance across which I want to find the voltage. So that's my interest, V naught. So now I have everything. V naught will be 19.2 divided by 10 plus 5, which is 15 times 10. That is the value of the voltage drop, VOC. So basically it's 19.2 times 2 over 3, whatever it is, I will leave it like that. So once calculated, that can be found. So this is the voltage drop across the 10 ohms resistance, and found in the by the method of Thevenin's theorem.